Imagine a newly discovered black hole, not just any black hole, but one intrinsically linked to 3IATLAS, the mysterious wanderer that once drifted through our solar system, defying every prediction, every model, every law of motion we trusted. Now, it appears the story did not end when 3IATLAS vanished beyond the edge of our telescopes. Because somewhere in the dark, something stirred. A gravitational ripple, faint but undeniable, a signal that spoke of unimaginable density, of an object bending not only space, but reason itself. What if its depths hold more than darkness? What if, within this shadow, lies a clue to the hidden architecture of reality? Tonight, we peer into that abyss. And together, we ask, what truly lies inside the 3IATLAS black hole late 2024? At the Haleakalob Observatory in Hawaii, the ATLAS survey team noticed a distortion, a gravitational lensing pattern unlike anything in their database. It wasn't light that revealed it. It was absence. A subtle bend in the background of the Milky Way's dust lanes, as if space itself had flinched. Within hours, data poured in from Chile, South Africa, and the Canaries. Each telescope saw the same thing, a region of space pulling at nearby stars with impossible precision, no supernova, no known pulsar. And yet the gravitational influence was immense, as though a singularity had emerged from nothing. The coordinates matched a trajectory, the last known path of 3IATLAS. Could an interstellar object have collapsed into a black hole? Or was it never a simple traveler to begin with? In observatories and universities, confusion turned quickly to obsession. Teams compared luminosity curves, cross-checked gravitational wave logs, and replayed archival footage. We knew black holes formed from dying stars, one researcher said, but this had no parent. Astrophysicists at the Event Horizon Telescope argued it could be a rogue microsingularity, an ancient remnant drifting between galaxies for eons. But there was something else. Its behavior wasn't passive. The gravitational field seemed to oscillate like a pulse. And deep within those oscillations, mathematicians detected harmonics, patterns too structured to be random. Some called it coincidence, others whispered of design. Every known black hole fits roughly into a scale. Stellar mass, intermediate, or supermassive, 3IATLAS fits none. Its estimated mass suggests an object barely 30 kilometers wide, yet its gravitational influence extends thousands of light years farther than theory allows. Around its periphery, a faint corona glows, not of accretion dust, but a delicate shimmer of high-energy photons behaving like Hawking radiation turned inside out. It was as if the event horizon itself were leaking light. Computational models failed repeatedly. The equations broke down. Energy seemed to vanish and reappear like a cosmic magician's trick performed with the laws of thermodynamics. Something about 3IATLAS refused to fit inside our definitions. It was the wrong size, the wrong color, the wrong kind of silence. And so, scientists did what humans always do when faced with the impossible. They looked closer. From the IceCube Neutrino Observatory buried beneath Antarctic ice to the laser interferometer in Washington, every instrument turned toward the coordinates. Gravitational waves arrived, faint, rhythmic, like the beating of a star's ghostly heart. Webb's infrared sensors traced a lattice of dust around the source, but inside that ring, nothing, a perfect void. Even radio telescopes found only silence, and silence, in astronomy, is rarely empty. They began to call it the still point, a place where gravity, light, and time stand in fragile truce, but behind the beauty lay fear. Because if the readings were correct, this black hole was moving, not orbiting. Not drifting, moving. accelerating toward a vector that pointed far beyond the Milky Way's arm. Where, or what, was it heading toward? Months passed. Dozens of theories collapsed under data. Some claimed a binary collapse, others a gravitational mirage. But none could explain the consistent pulse, a heartbeat that neither faded nor changed speed. At the Max Planck Institute, quantum cosmologists noticed that the frequency of that pulse mirrored the resonance of known Planck scale fluctuations, the same ripples thought to exist at the birth of the universe. If true, then 3IATLAS was not a remnant of creation, it was still creating. And somewhere inside that shadow, matter and spacetime might be rewriting themselves. No one wanted to believe it, but every equation pointed to the same impossible conclusion. Something inside 3IATLAS was alive, not biologically, but dynamically, a system evolving beyond event horizon isolation. The deeper we looked, the less we understood. And so began the great question, what exactly have we found? To understand 3IATLAS, astronomers turned to every tool the 21st century could offer. Optical telescopes traced its motion, infrared sensors studied its temperature, and deep beneath the ice of Antarctica, neutrino detectors waited listening for whispers of particles that pass through everything, even black holes. The first step was to determine what kind of gravitational body they were seeing. Was this an illusion of massa lens effect or a genuine collapse? For months, data from LIGO and Virgo hinted at faint gravitational waves, tiny wrinkles in the fabric of spacetime itself. Each wave arrived slightly out of phase, as though refracted by something spinning faster than physics should allow. The team fed the signal into a supercomputer at Caltech. The output was chaotic gravitational harmonics too complex for any single object. It was as if several masses were orbiting inside one another, dancing in a gravitational maze that refused to settle. To make sense of it, engineers built a model using layered interferometry light from multiple telescopes combined to create one vast virtual lens. For the first time, humanity could glimpse the region not as a dot of darkness, but as a dynamic field twisting arcs of distorted light spiraling into a central silence. Imagine looking into a whirlpool where the water doesn't fall inwards, it folds. Every photon entering that field stretched, bent, and seemed to change direction twice before vanishing. And then, for a fraction of a second, Webb caught a pulse of infrared light escaping from behind the event horizon itself. No one could explain it. Light is not supposed to come out. At MIT, theoretical physicists began mapping the radiation patterns. They found that the energy leaking from 3IATLAS matched no known form of Hawking radiation. Instead of a steady evaporation, it pulsed brief bursts every 42 minutes. That rhythm corresponded precisely to the gravitational oscillation detected months earlier. It was as though the black hole were breathing. Scientists proposed a radical possibility that the event horizon was fluctuating, expanding, and contracting in microscopic waves. This would mean the boundary between existence and nothingness was not fixed but alive with quantum turbulence. To test it, they compared it with archived data from Sagittarius A*, the supermassive black hole at the center of our galaxy. The contrast was immediate. Sagittarius A* was calm, stately, predictable. 3IATLAS was chaotic, rhythmic, and unreasonably small. It was behaving like a black hole that had learned to resonate. Some suggested it was a boson star, a cluster of exotic particles compressed so tightly that it mimicked a singularity without forming one. Others believed it was a magnetic monopole, a relic from the earliest moments after the Big Bang, but neither model could reproduce the gravitational pulse or the light leakage. Every time theory tried to trap 3IATLAS inside a definition, it slipped through the net. In January 2025, a joint team from NASA and CERN released preliminary findings. Their conclusion shocked even the skeptics. The object appeared to possess a variable mass signature. Its measurable gravity increased and decreased by nearly 3% every cycle. That should be impossible. Mass is not supposed to fluctuate. Yet the readings were consistent across independent observatories. Something was shifting inside that darkness. Something massive, unseen, and deliberate. Mathematicians began describing the phenomenon as living geometry, a self-correcting curvature of space-time. Computer visualizations show the event horizon rippling like the surface of a pond struck by invisible stones. These waves of distortion, gravitational echoes traveled outward, and by the time they reached Earth, they aligned with the pattern of cosmic background radiation left over from the dawn of the universe. Coincidence? Perhaps. But to physicists, it suggested an ancient rhythm, that the universe might still vibrate in harmony with its own creation. So where did it come from? If 3IATLAS was once an interstellar traveler, what force could have transformed it into a gravitational singularity? Archival data showed that before its disappearance, the object accelerated dramatically, as though drawn toward something unseen beyond Neptune's orbit. Some speculated a dormant micro-black hole captured it, while others dared to suggest it became one collapsing under an exotic trigger. One theory stood apart. It proposed that 3IATLAS interacted with a region of space dense with dark matter, and in that collision, ordinary mass inverted, creating a mirror singularity, an object that reflects gravity instead of absorbing it. If true, then what we call a black hole might not always consume, sometimes it might transform. By mid-2025, telescopes across 5 continents captured a faint burst of gamma rays from the coordinates of 3IATLAS. It lasted less than a second, but in that instant, the surrounding stars appeared to shift position. The effect could only be explained if the fabric of space had momentarily stretched, like a lens zooming out. Something inside the singularity had changed, a door had opened, or perhaps closed. For the first time, scientists considered a question once confined to science fiction. What if the center of a black hole is not an end, but a beginning? This discovery, they realized, could rewrite every textbook, every simulation, and every assumption about the nature of time. And yet, for all the data, one truth remained clear: we still had no idea what was inside. To look beyond the event horizon is to stare into our own ignorance, but that has never stopped us before. Up next, we cross that line, the boundary where known physics ends. What waits inside 3IATLAS may be more than gravity, more than matter, and perhaps more than reality itself. Beyond the edge of sight, beyond the reach of our mathematics, lies the one place nature hides all her secrets, the event horizon. It is not a surface in the ordinary sense, it is a threshold where time slows, light curves, and causality begins to whisper instead of speak. For decades we thought we knew what waited there. A singularity. Infinite density, zero volume, the ultimate dead end of physics. But 3IATLAS refuses that simplicity. Its signals suggest that something exists beyond the horizon, something structured, evolving, alive with patterns that should not persist inside oblivion. Inside the observatories, discussion turned toward exotic matter, substances predicted but never seen, whose gravity repels instead of attracts. If 3IATLAS contains even a trace of such matter, it could explain the oscillations, the breathing horizon, the leaks of impossible light. Quantum theorists modeled it as a sphere of negative energy wrapped around a core of compressed quark gluon plasma, a heart forged in the earliest microseconds of the universe. Within that heart, space might not collapse inward at all. It could rebound, folding into a bubble of false vacuum, a pocket universe suspended within our own. They called it a gravitational echo chamber. Every particle that falls in may rebound across time, emerging not elsewhere but elsewhen. No one can prove it, yet its equations fit the data better than any classical model. In early 2025, a new paper arrived from Princeton, a proposal so audacious it bordered on myth. What if 3IATLAS is not one black hole, but many? A hierarchy of nested singularities, each orbiting within the other, a cosmic matryoshka of gravity and time. The outermost shell pulses as its inner cores exchange energy, causing the mass fluctuations we observe. To visualize it, imagine throwing a pebble into a lake and watching smaller ripples circle inside the splash. Now replace water with space-time and the pebble with a black hole that swallowed its own reflection. Computer simulations produced astonishing results, self-stabilizing gravitational wells that could last billions of years. Each inner core could serve as a resonant cavity for quantum fields, echoing light and information between horizons like mirrors facing mirrors. If such a structure exists, then what we see from Earth is only the outer skin of an infinite recursion, a tunnel without end, folding inward forever. Then came the most controversial theory of all. Relativists revisited the long-dismissed idea of the Einstein-Rosen bridge, a wormhole connecting to distant regions of spacetime. They asked a forbidden question: could 3IATLAS be one end of such a bridge? The math was precarious, balanced on assumptions about exotic negative energy, but if correct, the periodic surges in radiation might be messages of geometry, space stretching across itself, matter sliding between dimensions like ink through paper fibers. Somewhere far beyond the reach of any telescope, another mouth of that bridge might exist, a twin horizon, invisible, waiting for our instruments to grow wise enough to find it. If so, then when we gaze into 3IATLAS, we may be looking not into a void, but through a window, a mirror that looks back. Every black hole should destroy information. Yet physics insists information cannot be lost. This contradiction, the information paradox, has haunted cosmology for half a century. Data from 3IATLAS now adds another voice to that argument. Its radiation carries tiny fluctuations, mathematically correlated with the pattern of matter that once fell in. In other words, it may be remembering. If verified, that means black holes are not graves. They are memory engines, cosmic archives compressing experience into quantum code. And if 3IATLAS records its own history, then somewhere inside, every atom it has consumed still whispers of the stars it once belonged to. We may never retrieve that information, but knowing it persists changes everything, because it means the universe forgets nothing. Among the physicists, one idea remains quietly unsaid, spoken only in hallways and midnight conferences. What if these patterns, these pulses of ordered chaos, are not random? What if they represent feedback? A form of cosmic self-awareness built from gravity itself. 3IATLAS could be more than matter. It could be a node in the universe's own network of cognition where space learns from its own curvature. It is a terrifying thought that consciousness may not be born from brains, but from geometry. That the cosmos thinks and we are its fleeting reflections. Of course, these are only theories. No probe has crossed an event horizon and returned. Yet new proposals emerge, quantum-entangled sensors, light sails guided by gravitational gradients, future missions designed to approach as close as nature allows. In simulations, one final moment repeats. As the probe nears the horizon, its signal stretches, slows, then freezes, a heartbeat suspended between seconds. To outside observers, it never crosses, but from the probe's perspective, it falls forever, perhaps to find that the fall itself is the destination. And maybe, just maybe, on the far side of 3IATLAS, spacetime begins again. We have traveled as far as theory allows. What waits beyond this line belongs to imagination and courage. But the questions 3IATLAS has raised will not fade. They mark the dawn of a new science, one that no longer asks only what the universe is, but why it behaves as though it knows we are watching. Every discovery bends the rules of what came before. But 3IATLAS does something more dangerous. It bends the rule makers. What began as an anomaly in a telescope feed has now become a mirror held to physics itself, and the reflection is cracked. For the first time in a century, Einstein's equations, the language that carried us to the stars, begin to tremble. In general relativity, gravity is geometry. Matter tells space how to curve, space tells matter how to move. But 3IATLAS seems to answer back. When researchers applied Einstein's field equations, the results oscillated, spinning between the possible curvatures as though the geometry were indecisive. It was a mathematical stutter, a spacetime that couldn't make up its mind. Einstein called his equations beautiful, but beauty alone cannot explain a heartbeat in the dark. To fit the data, theorists introduced a correction term, a feedback loop that allowed curvature itself to evolve over time. The new model suggested that gravity might be self-aware, responding to its own influence like an organism adjusting to pain. If true, the foundations of relativity, cause, effect, inertia, may be approximations of something deeper, something alive within the fabric of the cosmos. Relativity governs the vast, quantum mechanics rules the small. For generations, scientists have searched for a bridge between them, a single theory that explains both galaxies and atoms. Some thought the key lay in strings, tiny vibrating loops that compose all matter. Others looked to spin networks and loop quantum gravity, where space itself is woven from discrete quanta. But nowhere in the math was there room for a black hole that pulses, glows, and changes mass. Then came a revelation. When 3IATLAS's frequency was translated into quantum units, it matched the Planck scale vibration predicted by those same string theories. By accident, the universe had performed an experiment that the world's largest colliders could only dream of. It was as if 3IATLAS were teaching us the unifying equation by example, showing how quantum foam becomes gravity's ocean. Physicists now speak of quantum echoes, tiny signals that may prove the union of the two great pillars. Each echo is a signature, a whisper from the smallest scales that resonates through the largest. We have searched for quantum gravity in particle accelerators and computer models. But perhaps it was never confined to laboratories. Perhaps it was waiting, patiently, inside a wandering object named 3IATLAS. For generations, we believed that stars lived, died, and collapsed into singularities, their remnants drifting as black holes until the end of time. But 3IATLAS tells a different story, one of rebirth. If its structure truly shifts, if its mass breathes, then black holes may not be the tombs of stars. They may be cocoons. Imagine a universe where collapse is not death but transformation, where energy folds inward to gestate new physics, new space-time, perhaps even new universes. This vision forces astronomers to redraw the cycle of stellar life. Supernovae become seeds, black holes become wombs, and the cosmos becomes an endless chain of self-creation. At Cambridge, one researcher put it simply, maybe the universe is recycling itself. The implications reach beyond mathematics. If 3IATLAS breaks our theories, it also breaks our complacency. For centuries, we assumed understanding was inevitable, that every mystery would yield to reason. Now we glimpse something reason can describe but not contain. To confront 3IATLAS is to stand at the edge of our own imagination. We see patterns but cannot name them. We hear rhythms but cannot translate their music, and still we look. That persistence, the refusal to stop asking, is humanity's own form of gravity. It pulls us toward the unknown again and again, even when we know we might never return. What began as an interstellar visitor may now be the first message from a deeper layer of reality, a reminder that the universe is not a machine but a mystery, and that every equation we write is only the shadow of a greater truth. Up next, we turn toward the horizon of possibility, the missions now preparing to face the unknown and the question that no instrument can answer. What does this discovery say about us? Out there, beyond the reach of any probe, 3IATLAS still moves, a silent traveler wrapped in its own gravity, a question gliding through the dark. Even now, our instruments track its ghostly pull. Every shift, every ripple, adds one more fragment to the story. But no telescope, no equation can yet tell us what truly lies within, and so humanity prepares the next step. In control rooms across the planet, plans unfold quietly. The Event Horizon Telescope will expand to a dozen new stations, linking radio dishes from Chile to the Antarctic Plateau. A next-generation interferometer, the Aurelia Array, will attempt to capture the flicker of spacetime itself. Its sensors will not look for light, but for absence, the small tremor that a passing thought of gravity leaves in the void. Meanwhile, the European Helios probe prepares for launch, a wafer-thin craft designed to ride solar winds beyond Pluto and position itself along 3IATLAS's projected path. It carries quantum-entangled detectors to halves of one particle so that what one half experiences, the other records in real time across the void. It is the first attempt to let human technology feel what the universe feels. Each mission is more than machinery. It is the continuation of a single human gesture to reach, to understand, to touch what cannot be touched. We have learned that the cosmos does not surrender its secrets easily. It asks us to become better listeners, to slow down, to notice the faintest whisper between the stars. Perhaps the next discovery will come not from a telescope, but from a pattern recognized by an AI trained on silence. Perhaps it will come from a physicist who dreams equations and wakes with a new constant written in the margin of her sleep. Or perhaps the next message will come from 3IATLAS itself, a change in rhythm, a pulse that says, I'm still here. What do we do with knowledge that outgrows us when we finally peer into the heart of a black hole and find not destruction, but creation? What will that make of us? If the universe is a story, then black holes are its punctuation pauses between sentences, moments where meaning folds in on itself before continuing anew. Standing at the edge of one, we are reminded that curiosity is not a luxury, it is survival. The act of asking why keeps the species awake against the cosmic night. The more we learn about 3IATLAS, the smaller we seem, and yet, paradoxically, the more essential. We are the universe noticing its own complexity, eyes born of dust staring back into dust, and finding beauty instead of fear. Perhaps that is the true purpose of discovery, not to conquer the unknown, but to recognize ourselves within it. every equation carved into a chalkboard. Every telescope pointed skyward is an act of remembrance, a way for the cosmos to keep track of its own wondering. Someday, a future generation will stand on a distant outpost, watch 3IATLAS drift against a foreign sky, and finally know what lies inside. They may find another universe, they may find nothing at all, or they may find that the boundary between everything and nothing was never real, that it existed only in our perception. Until that day, we continue to listen. Every photon, every echo, every silence is a conversation across eternity. And perhaps somewhere inside that darkness, the universe listens back. This is not the end of the mystery. It is the beginning of awareness. What's inside 3IATLAS? Maybe everything we've ever wanted to understand, and everything we've yet to become.